Hi, and welcome to our fifth chemistry lesson. This one, we'll give you a brief introduction to acids and bases. So first, let's talk about acids. What is an acid specifically? There are many ways to define an acid, so let's look at some of the definitions. When we're talking about its physical properties, an acid is a chemical substance that neutralizes alkalis, which are often bases. They're kind of the inverse of each other. Dissolves some metals and turns litmus red, which is a paper indicator that turns red or blue based on the acidity level of the substance that it's like dipped in. And typically they are corrosive and sour tasting liquid, and they're always diluted in water. From a chemistry perspective, an acid is defined as a molecule or chemical substance that donates a proton or an H plus ion, because the hydrogen atom is just this. Because the hydrogen atom, as I was saying, is essentially just a proton and electron, the regular one that is. So when you have an H plus ion, it's just a proton. Additionally, a substance is acidic if it has a pH of less than 7. And that's a scale we'll go over at the end of this presentation. There are many ways to describe the properties of an acid, but simply an acid is a proton donor, is the simplest way to think about it. This means that in a reaction, an acid will release or give away an H plus ion, which is the same as a proton. Now let's look at some examples of acids. Citrus fruits like lemon and oranges have citric acid, which makes them acidic. They're actually pretty acidic. I believe they have a pH of around like 2, 3, or 4 in that range. Coffee, despite its bitter taste, which is actually a characteristic of a base, is acidic around 5.5, which is why some dentists tell you that coffee is bad for your teeth. Soda, this is probably obvious, is very acidic, around a 2. Terrible for you. Don't drink it, but it is an acid. And bananas, surprisingly, although they are fruit, which maybe makes it less surprising, bananas are slightly acidic.
All right, so next is a base. A base is any substance that in water solution is slippery to the touch, tastes bitter, changes the color of indicators. An example, turns red litmus paper blue, and reacts with acids to form salts and promotes certain chemical reactions. So from a chemist perspective, you could define a base as a proton acceptor, as sort of the opposite of an acid. Bases also produce more OH minus ions as opposed to H plus ions compared to acids. So there are a few ways to describe a base, but the simplest, just like an acid, is to remember that a base accepts a proton that is donated from an acid. So a few examples of bases are soap, Drano. Drano is, I'm sure it's pretty self-explanatory on there, cleans out shower drains or sink drains or anything of the kind. And water on the left here can actually act as both an acid and a base, but it has a pH of 7. So it depends.
Yeah,
it depends on the.
Sorry, this is an example of salt water, and salt water in the ocean is slightly basic. Although, like Dylan said, water's unique property is it acts as an acid and a base, so it's pretty cool.
Thank you for saving me there, Aaron. And pure baking soda and clear ammonia are 2 more examples of bases.
Yeah, and just to add on, many like strong cleaning products are bases, except for vinegar, which can also be used for cleaning. Yeah.
All right, so some physical properties of each. Some acids have sour taste, while bases have more of a bitter taste. Obviously, there was a discrepancy in that. Aaron noted that coffee is an acid, yet it has a bitter taste. Acids have a low pH, while bases are the opposite. They have a higher pH. Acids turn litmus paper red, while bases turn litmus paper blue. And an acid is corrosive, but a base is slippery to the touch.
Okay. So finally, we have the pH scale. Essentially, the pH scale measures acidity. And what it does is each number is a measurement, essentially, of the concentration of an H plus ion in a acidic or basic solution. And this is a good measure of how acidic a substance is, because that's kind of what acidity is. So stronger bases have way less concentrations of H plus ions, and stronger acids have way higher concentrations. And the scale is logarithmic. So as you go from the left to the right, each step is 10 times more acidic, or sorry, right to left, it's 10 times more acidic than the one before it, because it's a logarithmic scale. So the concentration of H plus ions in a drain cleaner with a pH of 14 is 1 times 10 to the negative 14th, like parts per liter, or whatever the unit, I don't remember. So then a 13 would be 1 times the negative third, or negative 13, and so on, until you get to 0, which is just a concentration of 1 mole essentially per liter. So really, it's a logarithmic scale. It's the main thing you want to take away. So for example, a banana, if it had a pH of 5, is actually 100 times more acidic than water, which is a neutral 7, because each step is 10. So it'd be 10 times 10 is 100 times more acidic. So that's the end of our presentation, and thank you for watching.
Thank you.